Hello, good evening, and welcome to my channel. In today's lesson, we'll be discussing trigonometry of the right angles triangles. Okay, so please, if you are new to this channel, please hit the subscription button below so you can follow us in this series of lessons. This is a special course in pre-calculus. So at the end of this lesson, you should be defined the trigonometry of the right angles. You should be able to state the trigonometric ratios of the right angle triangle, which are the 6 trigonometric ratios of the right angle triangle, and you should be able to apply these ratios to solve right angle triangle problem. You should be able to define degree measures. You should be able to define complementary angles and supplementary angles. You should be able to define radian measure. You should be able to convert from degrees to radian and from radians to degree. And you should be able to apply radian in the solution of right angle triangle. So let us continue with this lesson, guys. Alright, so as a checklist, from before, these ratios are not new. You are already familiar with the following ratios, which is sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, tan theta equals opposite over adjacent. And you know, of course, a right angle triangle is one who contains a 90-degree angle. The side facing the 90-degree angle is called the hypotenuse. The side facing angle theta, wherever you position theta, is called the opposite, and the side beside angle theta is called the adjacent. Okay, so the sine is pronounced as sine, not sin, sine, and cos, which is the short form of cosine, is cos, and tan, which is the short form of tangent, is tan. So these are the pronunciation, guys. But before we continue, let us define trigonometry. So what is trigonometry? Trigonometry comes from the two words which means trigono. Okay, trigono, it means trigono. So we have the two words which means trigono. Trigono means triangle, and then the word metric, which means measure. Okay, so trigonometry, combining the two words together, trigonometry is actually triangle measure. Okay, all form of triangles can have the right angle triangle. Okay, right angled or isosceles, equilateral, and a scaling triangle. So all this triangle can be measured using trigonometry from definition, which means triangle measure. But we will see later that trigonometry goes beyond triangle measure. It is actually the measures of angles in triangles. Okay, so that is about the origin of the word trigonometry. Now, skew check. Of course, from elementary trigonometry, you can calculate the following ratio. Find the side of our angle marked x. So for A, let us take A. So for A, we can see that the side we are looking for is the opposite. So this is the opposite, okay? And the side we are given is hypotenuse. So if we do opposite over hypotenuse, so opposite over hypotenuse, that is sine 35 degree. Okay, so sine 35 degree equals to 7 over x. So if we cross multiply, we are going to have that x, so that should be x over 7, not 7 over x. That is x over 7. So if we cross multiply, we have 7 times sine 35 degrees. Okay, if we use calculator or something, we are going to get the answer directly like that. So for the second one, for B, the side we are looking for, of course no angle is given here, so we can use Pythagoras theorem here. Pythagoras theorem, so which says x squared equals a squared minus 6 squared, and that is 64 minus 36, which is 24, 28. So we take the square root of both sides, we are going to have x equals the square root of 28, which is 2 root 7 centimeter. And then of course C, so we are looking for angle C. Okay, with respect to C, this is the adjacent and this is the hypotenuse. So that is cos x. Cos x equals to 3 over 8, which is 3 divided by 8, which is 0.375, and then x equals cos inverse 0.375. Okay, so cos inverse of that will give us 67.97. Okay, so this is our elementary trigonometry, and of course you solve right angle triangle by using SOHCAHTOA or SOHCAHTOA, okay, or by Pythagoras theorem. So these are two methods of solving right angle triangle. Now, so those are the basic ratios that you know before, but we have reciprocal ratios. Okay, we can find the reciprocal of sine, the reciprocal of cosine, the reciprocal of tangent. Okay, so and of course the reciprocal of sine, which is called cosecant, in short form cosec, okay, equals 1 over sine theta. Okay, and the one we call secant theta, which is the same thing as sec theta, equals 1 over cos theta. And the last one, which is called in full cotangent theta, which in short form we write as cot theta, is 1 over tan theta. Okay, so these are additional ratios we have in trigonometry, and they are called the reciprocal ratio. So reciprocal ratio. All right, so applying these ratios together, we have 6 of them. Okay, so let's solve this problem. Find the 6 trigonometric function for the right angle triangle. The 6 trigonometric function for the right angle triangle, that is, we are looking for a sine, cosine, and tangent, and there's cosecant, secant, and cotangent. So let's take the first triangle. So taking the first triangle, we have dot. Let's draw a rough sketch of the triangle this way. So this is right angle triangle, this is where phi is, so this symbol is pronounced as phi. Okay, the opposite of phi is 15, the adjacent is 8, and the hypotenuse of the triangle is 17. Okay, so we can label that properly. This is opposite, this is adjacent, and this is the hypotenuse. So defining our ratio, we have sine phi equals to opposite over hypotenuse, which is 15 over 7, cos phi equals to 8 over that is 8 over 17, and tan phi equals opposite over adjacent, which is 15 over 8. Okay, so these are the basic ratios here. Then we have the reciprocal ratio. Cosec phi equals 1 over sine phi, which is 17 over 15. Okay, sec phi equals 1 over cos phi, which is 17 over 8. And lastly, cot phi, which is 1 over tan phi, equals 8 over 15. So these are the 6 trigonometric ratios for the first triangle. Now you're going to pause this video and do the second one as an exercise. Alright, welcome back. Yeah. So for the second triangle, we have the right angle to be this. Okay. The angle is here, which is angle beta. The opposite of beta is 0.3. Rectangle here. The hypotenuse is 0.5, and the adjacent is 0.4. Okay. So now labeling both sides, we have this as the adjacent, this is the opposite, and this is the hypotenuse. So we can define, guys, the 6 trigonometric functions for this triangle as follows. So sine beta equals opposite, which is 0.3 over hypotenuse, which is 0.4, which if you multiply numerator and denominator by 10, multiplying them by 10, you have 3 over 5. Okay, cos beta equals 0.4 over 0.5, multiplying denominator and numerator by 10, you have 4 over 5, and tan beta, which is opposite, 0.3 over 0.4, multiplied by 10, which is 3 over 4. Now guys, we can define the reciprocal function as follows. Cosec beta equals 1 over sine beta, which is 5 over 3, and sec beta equals 1 over cos beta, which is 5 over 4, and lastly cot beta, which is 1 over tan beta, equals 4 over 3. So these are the basic trigonometric functions for this values, guys. This is how to define it. Alright. Next activity, we have given a function value of an acute angle sine theta equals 24 over 27. Find the other 5 trigonometric function values of theta. So when you have this kind of question, guys, the first thing you do is draw the triangle. So draw the right triangle this way. You can position your theta anywhere. So this is opposite, this is the hypotenuse. So here, the first thing we need to do is to find the adjacent. So let's put x there. So we can apply here Pythagoras theorem. Okay, so Pythagoras theorem applicable. So by Pythagoras theorem, x squared equals 25 squared minus 24 squared. Okay, applying the difference of two squares, that will be 25 plus 24 multiplied by 25 minus 24, and that is basically 49 multiplied by 1, which is 49. So taking the square root of both sides, you have x equals to square root of 49, which is 7. So guys, the adjacent is 7, and of course we can label our side as follows. This is the adjacent, and this is the hypotenuse. So we can find the other 5 trigonometric ratios following this principle. So cos theta equals 7/25, and tan theta equals 24/7. Okay, so cosec theta equals 1/sine theta, which is actually that will be 25/24, of course, and sec theta, which is 1/cos theta, that will be 25/7, and lastly cot theta, which is 1/tan theta, will be 7/24. These are the other 5 trigonometric function values for the particular triangle, guys, and then we are done. So you are going to pause this video, take this as a classwork, and then come back to check your answer. Welcome back, guys. Let's see if you are correct. So if sine beta equals to 2√3/3, cos beta equals to 1/3, and tan beta equals 2√2, find cosec beta. So let's take cosec beta. Cosec beta, of course, you know, is 1/sine beta, and that will be 3/2√2, and of course you have to rationalize the denominator, which is 3√2 all over 2 times 2, which is 3√2/4. So cos beta is 3√2/4, and then we can find sec beta, which is 1/cos beta, and that will be 3/1, which is 3. And lastly cot beta, which is 1/tan beta, that will be 1/2√2, and of course we have to rationalize, which is √2/2 times 2, which is √2/4. That's the final answer, guys. I believe you got it correctly. Alright, so degree measures. How do we define degree measures? What are degree measures? Okay, so the measure of angle is determined by the amount of rotation anti-clockwise from the x-axis for positive angles and clockwise from the x-axis for negative angles. So of course what we are trying to say here is that positive angles are measured anti-clockwise from the x-axis, and negative angles are measured clockwise from the positive x-axis. Okay, and angle is a measure of the amount of rotation you have in an angle. So this arm that you have here is called the terminal side, which is the rotating side. Okay, and the distance between the amount of rotation and the positive x-axis is known as theta. So this region defines theta, and of course you know that the total angle in a circle is 360 degrees. So if you start from 0 and you rotate a complete cycle anti-clockwise, you move from 0 to 360 degrees, and the circle can be divided into 4 quadrants. Okay, so the first quadrant is between 0 and 90 degrees. The second quadrant is between 90 degrees and 180 degrees. The third quadrant is between 180 degrees and 270 degrees, and the fourth quadrant is between 270 degrees and 360 degrees. So these are the 4 quadrants we have in circular angles rotation. So guys, complementary and supplementary angles. So remember that complementary angles add up to 180 degrees. Okay, they add up to 180 degrees. So here complementary angle add up to 90 degrees. Sorry, so here alpha plus beta is 90 degree, and alpha equals to 90 degree minus beta, and of course beta equals to 90 degree minus alpha, while supplementary angles add up to 180 degree. So alpha plus beta equals to 180 degree, and alpha equals 180 minus beta, and beta equals 180 degree minus alpha. So complementary angles add up to 90 degree, and supplementary angles add up to 180 degree. So another thing you should also remember here, guys, is that sine theta equals to cos 90 degree minus b theta, and cos theta equals to sine 90 degree minus theta. Okay, so we also have other ones like tan theta equals to cos 90 degree minus theta, and cos theta as well equals to tan 90 degree minus theta. And lastly, we have sec theta equals to cosec 90 degree minus theta, and cosec theta equals to sec 90 degree minus theta. Okay, so actually this expression we have just written down is called cofunctions. Okay, you can call them cofunctions. So it is always true, and they are called cofunctions. Activity 4. Find, if possible, the complement and supplement of the angles. So you should be able to do this. So we can take our complement, so complements, and the supplement. So complement of this one is 90 minus 24, which is 66 degree, and the supplement is 180 minus 24, which is 156 degree. Okay, for this one there is no complement because the angle is more than 90 degree, but we have the supplement, which is 180 minus 29 degree, which is 51 degree. And this one we can calculate the supplement as 90 minus 87 degree, which is 3 degree, and the supplement is 180 minus 87 degree, which is 93 degree. And lastly, for this one there is no supplement, there is no complement, but the supplement is 180 minus 167 degree, which is just 13 degree. No, 13 degree. Yeah, carry one, so it's 13 degree. So this is how to find supplement and complement of angles. Now our next subtopic is radian measure. Okay, so if you want to measure radian, you have to have a circle whose radius cuts out an equal arc length. So in this circle the radius and the arc length are equal. So when this happens, the angle between the radius is called radian. So 1 radian is the measure of a central angle theta that intercepts an arc S equal in length to the radius of the circle. Okay, algebraically this means that theta equals to x over r, where theta is measured in radian. And how do we come about this formula? You know that the circumference of a circle is 2 pi r. Okay, and circumference of an arc equals to theta over 360 times 2 pi r. Okay, so in radian measure 180 equals to pi, and 360 equals to 2 pi. Okay, so this will become a theta over 2 pi multiplied by 2 pi r. So 2 pi cancel 2 pi, we have length of arc theta multiplied by r. So here see arc, if circumference of arc or the length of the arc equals to x, we have s equals theta multiplied by r, and therefore theta equals to x over r in radian. Okay, so this is how we came about this formula. So what is important to note here is how to convert between degrees to radian and from radians to degree. So to convert radians to degree, you multiply the degrees by pi radian over 180 degree. And to convert degrees to radian, multiply the degree by pi radian over 180 degree. And to convert radians to degree, you multiply the radians by 180 over pi radian. So note that pi radian equals to 180 degree. Pi radians is always equal to 180 degree. So let's look at these activities. Determine the quadrant in which each angle lies. The angle measure is given in radian. So for us to determine the quadrant, we have to convert to degrees. So let us convert to degree. For number 1a, we have pi over 6 radian. So this is pi over 6 times 180 degree over pi radian. To convert to degrees, so here we have 30 degrees. So this angle is 30 degree, and that is our first quadrant. Okay, so for 1b, we have 5 pi over 4 radian. So in degree, that will be 5 pi over 4 times 180 degree over pi. Pi will cancel pi, and we have 4 here. 4 here is a 2 or 4. 4 times 4 is 16. 4 and 20 is 45. 45 times 5, that should be 5 20 225 degree, and that is actually third quadrant. Okay, so you can practice the other one, but let's take 2b, which is negative. So minus 5 pi over 3 radian equals to minus 5 pi over 3 times 180 degrees over pi. So 180 will cancel 180. 3 here is 60 degrees. 60 times minus 5, that's minus 300 degrees. And of course, you know that if you are measuring 300 degrees circular, so you have your quadrantal angle this way, and if you are measuring 300 degrees, you have to go this way. This is 90, this is 180, this is 270, and this is 300. So your angle is going to possibly lie here. So this is 300 degree. Okay, so the angle is in the first quadrant. All right. Activity 6. We write each of the following in radian measure as a multiple of pi. So let's take 1a. So 1a, we have 30 degree. So convert to radian, you multiply by pi over 180. So 0 cancels 0. This is 6, which is pi over 6 radian. Okay, for 1b, that's 150 equals to 150 degree times pi over 180 degree radian. So 0 cancels 0, 3 here 5, 3 here 6, and this is 5 pi all over 6 radian. And 2a, that's 315 degree equals to 315 degree multiplied by pi all over 180 degree radian. So 0, 5 here, 5 in 30 we have 6, 15 we have 3, 5 here we have 3 times 3 is 15, 5 in 30 we have 6, this is 36 degree. Okay, so you kind of a lot of this. So 36 degree, 3 can go, so 3 here we have 12 and 3 here we have 21. 3 can still go, 3 here 7 and 3 here we have 4. So the answer is 7 pi over 4 radian. So this is how to convert from degrees to radian and from radian to degrees, and because you can try out the remaining one. Very simple and straightforward. Rewrite each angle in degree measure. So that's converting from radian to degree. So for number 1a, we have 3 pi over 2 equals to 3 pi, that's radian, over 2 times 180 over pi radian. So pi cancel pi, we have 90 degree, and the answer is 270 degree. For 2a, we have minus 4 pi radian equals minus 4 pi times 180 degree all over pi. Pi cancels pi, and that is 0. 4 times 8 is 32, carry 3, 720, 720 degree. And for 3a, we have 7 pi over 3 radian equals to 7 pi all over 3 times 180 over pi. So 3 goes in 3, 3 here 1, 3 in 180 is 60, and 7 times 60 is gonna be 420 degree. So this is how to convert from degrees to radian. Simple and straightforward. Alright guys, so we have trigonometric ratios of special angles. Okay, so angles 45 degrees, 60 degrees and 30 degrees are special angles. They're special in that you can obtain their value without using calculator or 4-figure table. So they are special. So to find special angles 45 degree, we use an isosceles right angle triangle. Side are equal and the side are 1. So by Pythagoras theorem, 1 plus 1 equals to 2. So that's x squared. So x equals to square root of 2 and get the hypotenuse. And of course, we can define the ratio of angle 45 degree to be sine 45 degree equals 1 over root 2. Okay, which is root 2 over 2. Cos 45 degree is also equals to root 2 over 2. Tan 45 degree equals 1 over 1, which is 1. So from here we can obtain our cosec 45 degree to be 2 over root 2, which is 2 root 2 over 2, which is just root 2. Okay, and sec of 45 degree equals to cosec 45 degree, which is root 2, and cot 45 degree as well is equal to 1. So these are the ratio of special angle 45 degree. Alright, so we can obtain that of 60 degree and 30 degree. So evaluating trigonometric functions of 30 degree and 60 degree. So we use an equilateral triangle which all sides are equal. Okay, so all the sides are 2 centimeters. 2 centimeters. So the height divided the base into 2 equals half 1. And by Pythagoras theorem, you can have x, find the height to be square root of 2 squared plus 1 squared, which is square root of that should be 2 squared minus 1 squared. 2 squared minus 1 squared, which is square root of 3. Okay, so that is how the height is obtained to be 3. So we can find the opposite of 30. This is the opposite of 30. This is the adjacent of 30. And for 60, this is the opposite of 60, and this is the adjacent of 60. So let's start from 30 degree. So of course that means sine 30 degree equals 1 over 2, cos 30 degree equals root 3 over 2, and tan 30 degree equals 1 over root 3, which is actually root 3 over 3. So from this ratio we can obtain the reciprocal ratio. Cosec 30 equals to 2, or sec 30 degree equals to 2 over root 3, which is 2 root 3 over 3, and cot 30 degree equals 3 over root 3, which is actually 3 root 3 over 3, which is just root 3. Okay. Now for 60 degree, and obtain 60 degree as sine 60 degree equals root 3 over 2, cos 60 degree equals 1 over 2, and tan 60 degree equals root 3. Okay, so and then from there we can obtain cosec 60 degree to be 2 root 3 over 3, okay, and sec 60 degree to be equals to 2, and then cot 60 degree equals to 1 over root 3, which is root 3 over 3. So these are the special angles of 30 degree and 60 degrees. So the easiest way to memorize this is to memorize the triangle. Okay, as it may not be easy to memorize the value, but if you can picturize the triangle in your memory, you can solve many problems. Alright, so study step. These are the value of the trigonometric function. You can look at them, memorize them, and take them where you need them. So examples, let's consider examples of application of these ratios. So without using calculator, find the exact value of each of the following. So all you need to do is to draw your small triangles so you can remember them. First one is 45 degree. This is 1 root 2. The second one is 60 30. This is 60. This is 30. Okay. So this place is root 3. This is 1. This is 2. And then we can do a lot of things with this triangle if you remember to sketch them. Alright. So now for A, tan 30 over cos 60 equals to tan 30 is 1 over root 3 divided by cos 60, which is 1 over 2. So and this is 1 over root 3 times 2, which is 2 over root 3, which is 2 root 3 over 3. That's the answer for that. So we have B, sine 30 cos 60 all over cos 45 minus tan 45. So if we substitute what we have, sine 30 is 1 over 2 times cos 60, which is 1 over 2 as well, everything over cos 45, which is root 2 over 2 minus tan 45, which is minus 1. So we can simplify this to be 1 over 4 divided by root 2 minus 2 all over 2. Okay, and that can actually give us 1 over 4 times 2 over root 2 minus 2. So 2 here, 1, 2 here, 2. So that will give us 1 over 2 root 2. So we can rationalize the denominator to be root 2 minus 2 all over root 2 plus 2. The conjugate is root 2 plus 2. So that will give us root 2 plus 2 all over 2 minus 4, which is root 2 plus 2 all over 2 into minus 2, which is root 2 plus 2 all over minus 4. And guys, it can give us 1 over 4 times root 2 plus 2. That's the final answer. Alright, so we have other examples here. In exercise 25 to 38, find the exact value of each expression. So we can sketch the triangle for us to remember for 45, because remember this is 1, this is 1, this is root 2. And of course for number 25, we have sine 45 plus cos 45 equals root 2 over 2 plus root 2 over 2, which is 2 root 2 over 2, which is root 2. So for 26, we have cosec 45 minus sec 45, and that will be cosec 45 is 1 over sine 45, which is 2 over root 2 minus 2 over root 2, and that is 2 minus 2 over root 2, which is 0 over root 2, which is 0. Okay, very simple and straightforward. We are taking the next example. We have 27. So for 27, we have sine 30 cos 60 minus tan 45. So sine 30 is 1 over 2 times cos 60, which is 1 over 2, minus tan 45, which is 1. And this is 1 over 4 minus 1, which is 1 minus 4 over 4, which is minus 3 over 4. And that is the final answer. And for 28, we have cosec 60. Okay, that is cosec. So we have cosec 60 sec 30 plus cos 45 degree. Okay, so simplifying this, of course you know that sine 60 is root 3 over 2, so cosec 60 will be 2 over root 3 multiplied by sec 30. Cos 30 is root 3 over 2, so sec 30 will also be 2 over root 3 plus cot 45, which is 1. So this is 4 over 3 plus 1, which is 4 plus 3 all over 3. Right, so which is 7 over 3. 7 over 3. And lastly, we can have 30 as cosec square 60 degree, sec square 30 degree, plus cot square 225 degree. So first thing, you know, cosec square 60, which is sine 60 is sine 60 is root 3 over 2. Yeah, so cosec 60 is 2 over root 3. So this is 2 over root 3 square times sec 30, which is 2 over root 3 all square, plus cot square 225. This is in the third quadrant, so that is 225 minus 180, and of course it is positive because it is in the third quadrant. So this is 4 over 3 times 4 over 3 plus cos square 45 degree, which is still positive. So this is 16 over 9 plus cos square 45, of course that is 1 square, which is 16 over 9 plus 1, which is 16 plus 9 all over 9, and that is actually 25 over 9. So the final answer is 25 over 9. That is the final answer. So alright guys, so this is the end of the video. If you enjoyed this lesson, please remember to hit the subscription button below so you get our next video and succeed and be blessed as you watch. Bye for now.